We're going to go ahead and take a look at the graphs of quadratic functions today. We're going to look at a different form of quadratics. You're used to looking at the standard form, which is y is equal to an ax squared plus a bx plus a c. Today we're going to look at what's referred to as the vertex form. When it's in the vertex form, the number that's, because it's kind of factored here, using the idea of completing the square is really where it comes from. The number that's after the x minus is the x coordinate of your vertex. And what's after the parentheses is the y coordinate of your vertex. Now, we know the x coordinate of your vertex always tells you your axis of symmetry. So your axis of symmetry would just be x equals h, because h is your x coordinate of your vertex. Now, your vertex form helps you easily identify your vertex, your axis of symmetry, your direction of opening, because that's given to you by the number in front. If it's positive, it opens up. If it's negative, it opens down. Also, it tells you how it's translated from your normal basic parabola, because what's being subtracted to the x in this form tells you how far right it's going. What's being added to it afterwards tells you how far up it's going for your translation. So let's take a look at this one here. Since it's in the standard form, your vertex is 3, 2. It's always the opposite of what's after the x. Here it's a -3. It's the opposite of that. And it's always the same as what's afterwards. So your axis of symmetry is always going to be x equals whatever the x coordinate of your vertex is. Now there's a couple ways you could go about graphing this. You could make a t-chart. So you could choose a couple numbers on each side of 3 and go ahead and plug those into your equation up here to figure out your y values and plot your points. However, there is an easier way. You could go to your vertex 3 over, 2 up. Then you could follow this pattern here. Over 1, up 1. So over 1, up 1. And that works from both sides of your vertex. Then you want to go from those points, you want to go over 1, up 3. So over 1, up 3. Or from this point to the left 1, up 3. And then you could get another point by going over 1, up 5. Over 1, up 5, which ends up being off the screen. Now, you can always use this pattern right here for graphing quadratics. It works all the time. So here we would go. By the way, if we would have had a negative in front of your squared term here, instead of going up, we would have been going down. Now, on a side note here, if we would have had in front, instead of a 1 like we did here, if we would have had, say, a 3 in front, from your vertex, instead of going over 1, up 1, you'd have to go over 1, up the same number that's in front of your squared term times that 1. And so the pattern of the 1, 3, 5, 7, if there's a number in front, you got to just multiply that pattern by that number that's in front of your squared term for finding your points. So let's take a look at the next one here. Let's go ahead and get this in our standard quadratic or vertex form. It's not. So we're really going to have to complete the square. There's really two ways to complete the square. One of them is what we talked about before, getting the variables by themselves. So you want to get your x's by themselves, so you want to subtract the 4. And so we get this. Then you want to take half of your b, so half of your 2, and square that. And you want to add that on the right side, add that on the left side. Now on the left side, we just get y minus 3. On the right side, it factors into 2 identical parentheses. And then you'd want to finish getting y by itself. Your vertex then is always the opposite of what's after the x, the same as what's after the parentheses. Now that's one way to go ahead and complete the square. That's where you go ahead and take stuff to the left side, complete the square, and then you got to bring it back to the right side. There is another way you could do it. You could just go ahead, keep everything on the same side away from the y's, group your x's together. So I put parentheses around them. Then you want to go ahead and say, okay, if I Got to get the coefficient in front of your squared term to be 1. In this case, it was, but I'm going to still put a 1 out here in front just to help you see that. So now you got to figure out, okay, got to complete the square. I got to take half of the 2 and square it and put it here. Well, when I do that, I am going to have a plus 1 squared here. But now if I added this here, if I'm keeping everything on the same side and I add something, I'd also have to subtract something. So that's why after my 4, I have a minus my 1, because that's what's in front of my squared term that's multiplied by the red number times the red number. So this blue and red thing here undoes the blue times the red that I added here. So then I'd have my 1 in front, the parentheses would factor, and then I'd simplify what's afterwards. You can complete the square either way, it does not make a difference. Now, some of you will like this way over here. When you end up having a number in front of your squared term, other than a 1, this method over here in black is a lot shorter. But some of you may not like that. If you don't mind doing a few more steps and find it easier to follow, go ahead and do that way. I don't really care which way you do it. Now, your axis of symmetry, remember, is always x equaling your x-coordinate. And then go ahead and plot your points. So you go left 1, up 3. Since it's a positive in front, you know you're opening up, and then you can use that pattern of over 1, up 1, over 1, up 1, over 1, up 3, over 1, up 3, and so on, and then just connect your points. And so then you get a graph that looks like this. So let's go ahead and complete the square here. Once again, we'll do the 2 different ways. The first way, we'll do it the blue way first, and then we'll come back and do the red way. You want to group your variables together. Get the number in front of your squared term to be a 1, so you got to factor that negative 3 out of just the x's. Then you got to figure out, okay, what do I have to add here to fill in the space? And it's always half of your b, which is 2 in this case, squared. So it's a 1 squared. And then I'd have to undo that out here. Now, that's why since I added here, I got to subtract out here. It's a negative 3 here because it's really a negative 3 times that 1 squared I put here. So I need to subtract that negative 3 times my 1 squared out back to offset that. It's a negative 3, factor the parentheses, simplify what's after the parentheses. That's doing it the blue way. If we do it the red way, you got to get the coefficient in front of your squared term to be 1. So divide everything by negative 3. Then you got to get the x's by themselves. So you'd have to go ahead and add a 4/3 to both sides. Okay? Now, let's go ahead and look at this. So you need to now go ahead and add half of b squared. Well, b is this, half of that's 1, so you got to add a 1 to each side. So the right side's going to factor. The left side, you can go ahead and combine your like terms. Remember, this is 3 over 3 when you add it to your fraction. Then you got to go ahead and get y by itself. So that means you need to go ahead and get rid of the 3. So multiply the left side by 3, multiply the right side by 3. Then you got to get rid of the 7. So you got to subtract the 7 from each side. Then you got to get rid of the negative in front of the y. So multiply the left side by negative 1, multiply this term by negative 1, and then multiply this by negative 1. And well, lo and behold, you get the same answers we had before. So your vertex, once again, is always the opposite of what's after the x, and the same as what's afterwards. So you have your axis of symmetry. Then you just want to go ahead and plot your points. Now you're going to have to multiply that pattern of 1, 3, 5, 7 by the negative 3 here when you plot your points, and you get this graph. We're going to do one last thing here with the vertex form. Sometimes you need to work backwards from a graph or a set of information to be able to find the equation. Well, here you're given the vertex, and you're given a point that it passes through. Now, in the standard form, that means you'd have to find your y is equal to your a, x squared, plus your bx, plus your c. You'd have to go ahead and find your a, your b, and your c, three things. Well, in your vertex form, you need to go ahead and find three things also. So why would we want to choose the vertex form here? Well, we're given a vertex of your x and your y coordinate of your vertex, so we automatically know 2 out of the 3 in this form. Doesn't help us find any of the 3 in this form. So that's why we'd want to use your vertex form. So we know our h is your x coordinate of -1, and your y is your of your vertex, which is 4, is your k value. So you can plug that right into your vertex form. So it's x minus the -1 or x plus 1. So now all we have to do is go ahead and try to find a. To find your a value here, I'm going to take my point of 2, 1, plug that in for my x, which is 2, and my y, which is 1, to be able to help me out. Well, when I do that, I have my 1 is equal to an a times my x coordinate of 2 plus 1 all squared plus 4. Solving this for a then tells me my a value is -1/3. All I want to do then is go back to this red equation right over here, leaving my h and my k alone because that's my vertex and they're not going to change, and just replace my a value with what we figured it out to be, and that's what we're looking for.